I'm going over the statistical tests for determining if there is a correlation between variables. First, we have to set some definitions. A population is all the individuals you're interested in learning about, while the sample is a small group of those individuals that you're actually collecting data from. Note that the data from the sample might vary a bit from the population, but it's close enough to the population that we can use it. Variables are what you collect data about, and it comes in two types, a categorical variable and a quantitative variable. A categorical variable is data that falls into categories or groups. These are counts of the numbers of observation of each variable that you see. For example, the number of orange leaves found in a tree. Quantitative or numeric variables are data whose numerical values have a significance. You can calculate the mean, the median, the range, basically distributions of the data. An example is the heights of the football players on certain teams. Once you have these variables, we can go about analyzing them. If you have one categorical variable, we can see if there's a difference in the number of each categorical data. For instance, we can have the issue of, are the proportions of each colored marble the same for all the marbles in the toy store? And then this is kind of shown in the graph below here. When we have one categorical variable, we use a one sample proportion test. Using some analytical tests, we can go from sample data to make population conclusions. Using the one sample proportion test, we can either say there's most likely a difference between the amounts of each marble, or there's no conclusive evidence to say that there are differences in the proportion of each marble color. Then, if we have more than two categorical variables, we use a chi-square test. When we have two or more categorical variables, we see if one categorical variable's proportion differs depending on which of the other category it is in. For instance, does the proportion of students whose color their hair a non-natural color depend on their education level? Using the chi-square test, we can conclude if variables are dependent on each other or independent of each other. Moving on to quantitative variables, if you had one quantitative variable, we can see if our summary value, for example, a mean or median, of our data differs from our expected value. This is some value that we already had from before we started the experiment. For instance, is the average fish weight of the fishes in the pond different from last year's average? When we're doing one quantitative variable test, we call this a t-test, and we see if there's a difference or there's no statistical difference between the value that we got and our expected value. Then if we have two quantitative variables, we do a correlation test where we see if there's a correlation between the two variables. In this example shown here, we are checking if there's a correlation between the tail length of a leopard gecko and how much food it eats. The last type of test that we're going over is a categorical versus quantitative variable. If we have one category, then we're using a t-test, but if you have more than two categories, then we're using an ANOVA test. This example here, we have a categorical variable that has two categories, so we'll be using a t-test. Here, we're seeing if the age of fruit fly deaths differs due to gender. In other words, if we had a female fruit fly, is the average age of death going to be different from that if it was a male fruit fly? With this t-test or ANOVA test that we use here, we can either say there's most likely a difference between the death age of the two genders, or there's no conclusive evidence to say that there is a difference, so we cannot conclude anything. Now, I've been saying about checking if there's a difference or not a difference, but how you exactly go about saying, from concluding from these tests and saying that there is or is not a distance is with a p-value. A p-value tells you how likely you are to get the sample data that you got by chance, assuming that there's no correlation or difference between the two variables. Now, if your p-value is really, really small and below a set standard value, then there's most likely some form of correlation between your variables. A very small p-value basically means that it's extremely rare that you got your sample data by chance. Meanwhile, if you had a p-value that's above that set value, you can't conclude that there is correlation, as your sample data has a reasonable chance of occurring due to the random selection processes that we talked about before. And this is my works cited.